Good afternoon, everyone, and welcome to the NET212 session, Navigating the AWS Network with the Right Tools for the Job. My name is Nishant Kumar, and I'm a Senior Product Manager in the EC2 networking team, and I'm super excited today to talk to you about some of the native AWS features and tools that you can use for your day-to-day operations. Ankush, you want to introduce yourself?
Hi everyone, this is Ankush Goyal. I'm a Senior Technical Account Manager at AWS. I'm looking forward to presenting this session along with Nishant today. Thank you.
All right, before we start, some important housekeeping items. So this is going to be a level 200 session. So we expect that people here are familiar with the common AWS networking constructs. In today's session, we will be covering a bunch of features. So please keep a lookout for the QR codes in case you are interested to learn more about any of the particular topic. And finally, we will be using multiple sample architectures throughout the session, and we'll let you know when the build out is ready so that you can take a screenshot. So before we talk about all the tools and features, let's take a step back and think about what does a typical customer journey look like as they start building on AWS. And then we will also talk a little bit about what exactly customers need, and then we will go on to talk about how these tools can help you accomplish these tasks. So when you think about a typical customer journey on AWS and when they start building, it's very common that they would have instances in the public subnet which would need to access the internet or some of the services like S3, Lambda, DynamoDB, and in that case they can use things like internet gateway. Now, you will also have instances in the private subnet which would need connectivity, and in those cases you can use a NAT gateway. And we also have interface endpoints and gateway endpoints to help you connect to other AWS services like DynamoDB, Lambda. Now, when it comes to connecting your AWS workloads to on-premises, you have again two options. One of them is site-to-site VPN, and the other option is using a direct connect gateway. Now, so far whatever I have been talking has been in the context of one single VPC, but it's common that as customers start expanding, they will add other VPCs as well. So in those scenarios, it's very common to use a VPC peering service to connect your VPCs, and your VPC could be in the same region or different AWS regions, and you can use VPC peering. Finally, what starts happening is that as customers start scaling, now they would be in scenarios where they might have hundreds or thousands of VPCs. In that cases, for simplifying management of managing so many of VPCs, Cloud WAN and Transit Gateway are some of the most common services that is used for connectivity. And when it comes to connecting to your on-premises network, again, you can continue using services like site-to-site VPN and AWS Direct Connect. And if you are using Transit Gateway and you need to connect your VPCs that are spread across different AWS regions, you can use the Transit Gateway cross-region pairing capability. And finally, there are scenarios where customers would want to access workloads or applications that is hosted in the third-party network, which is also built on AWS. So in that case, if you want to keep your traffic within the AWS network itself, you can use service like Private Link. Now, as you can see, by the way, I did not go into all the services, but the point was to show you the different variety of AWS network connectivity options that is available. And depending on the customer use case, what we typically see is that customers use a bunch of them in tandem. And when you have to manage such a large network, it's obvious that to do your job effectively, you need certain tools and features that not only makes the job faster, but also efficient. So now let's talk about what do customers need? What are customers looking for? So at a high level, when you think about it, as a customer, you are thinking, am I architecting my network in a way that I can scale effectively? I should be able to understand the various costs of all the networking services that I am using, and are there any opportunities for optimizing these costs. You also need to make sure that you understand the connectivity performance and be able to troubleshoot any issues that might be happening. And finally, you also want to make sure that you understand the traffic pattern throughout your network so that you can quickly identify any unintended traffic or anomalous traffic, so you can quickly act on it. And finally, you need to make sure that your network is both secure and compliant and continues to meet your organizational's best practices. But let's take these requirements one step higher and think about what is needed to do these tasks effectively. So as a customer, what I need is the ability to visualize my network. I should be able to understand the various traffic patterns within my network. I should be able to understand how 2 points within my network are reachable, what paths they are taking, what are the various hops that is involved in this connectivity. And finally, I should be able to identify and troubleshoot any performance or connectivity related issues for my network. So effectively, what it translates into is, as a customer, what I want is that I should be able to effectively observe, analyze, and troubleshoot my network. So in today's session, we will be talking about a bunch of features, as you can see here on the screen, across all of these 3 categories, and talk to you about how you can use them in your day-to-day operations. And before we proceed, just a quick note, this is not meant to be an exhaustive list of all the features that is available, but in the interest of time, what we have ensured is that we focus on the select features that can be used across a wide variety of customer architecture that we see customers using today. So we are going to start with the observe section, and we will be talking about 2 features here, resource map and AWS network manager. So I'm going to start first with resource map. So what is resource map? Resource map is a VPC feature that helps you to visualize your VPC resources as well as the associated routing of these resources on a single page. So essentially what it helps you is to quickly visualize the architectural layout of your VPC. So if you take this example here that I have on the screen, for this particular VPC, as you can see, I have 6 subnets spread across 2 availability zones in the US East 1A and 1B region. Then you can see how they are connected to the various route tables, and then finally how these route tables are connected to the other connectivity services like a VPC endpoint or the NAT gateways or the internet gateway. So this helps you quickly understand the relationship between the various moving pieces within your VPC. And a cool thing of being able to visualize like this is that this comes in handy even with troubleshooting as well. So let's take an example here. So one of my subnets, the private 1B subnet in the US East 1B availability zone, is unable to reach the internet, and now I want to understand what exactly is going on. So if you look here, what you will see is that it is still connected to the default route table, but that default route table is not connected to any of the NAT gateways. So now within seconds in this case, you know what is the issue. And now the other cool thing with resource map is you can quickly click on the, you can quickly click on the screen here to go to that page so that you can make the necessary changes and fix the issue. So the whole idea with resource map essentially is that what we realized and saw customers facing issue was that they had to practically mentally map out all of these moving pieces in their head, and this was obviously not efficient, and it was also not it was error prone. So with resource map, we wanted to solve this problem, and I think it shouldn't come as a surprise to any one of you here. It is highly popular among the developer community. So next time when you are creating a VPC in the AWS console, please do check it out. All right. So now moving on to the next topic, let's focus on AWS Network Manager. So before I talk about that, if you remember when I showed you the architecture, I talked about that scenario where customers, when they have hundreds or thousands of VPCs, it's quite common for them to use a transit gateway network, a transit gateway or a Cloud WAN service to connect these VPCs as well as to connect to on-premises workload using services like site-to-site VPN or Direct Connect. So where Network Manager comes into picture is that it helps you get a quick end-to-end network topology view in a single place. So let's take an example here again. So in this case, I have three AWS regions. So my workloads are in three AWS regions in Oregon, Singapore, and Sydney. And I have a remote office in Auckland, which is connected to the Sydney AWS region using site-to-site VPN. And I'm using Cloud WAN to do this connectivity. So using Network Manager, you can quickly visualize all your topology in a single page. And you can do the same with Transit Gateway as well. So in this case, we have the same architecture that was built using Cloud WAN, but the only difference here is that you also have an additional office in San Francisco connecting to the workloads in AWS Oregon region. So let me show you another view within the Network Manager. So as you can see, not only can you see the logical network topology, but you can also visualize your topology based on the actual geographical location of your network. And this is not all. You can also monitor the network health of these connections. So let's focus on the site-to-site VPN connection with the Auckland office as well as the AWS Sydney region. So you will notice here that one of the tunnels in the site-to-site VPN connection is actually marked in red, which indicates that the connection, one of the tunnels is down. And if you want to get quickly the details, the site details, you can click here and you can navigate out to the different console to see what the configuration is there. Now, one of the things that people sometimes don't realize with Network Manager is that not only can you visualize your AWS resources, but you can also visualize your on-premises resources that is connecting to the AWS network. So you can do this using either the CLI or the console. So the example that I'm taking here or I'm showing here is the Auckland office that is connecting using the site-to-site VPN service. So you can register that site in Network Manager, and then you can go ahead and add the device. So the device here represents the device on the on-premise network that is establishing the VPN connection. And for folks familiar with VPN service, they will know that we call it as customer gateway devices. So you can again register them, and this will allow you to visualize these devices on the Network Manager topology as well. And this is just an example of how you can accomplish this using the CLIs as well. Now, there are two other important capabilities within Network Manager that I want to talk about, which is highly popular among our customers. So one of them is the ability to visualize some of the key metrics associated with your transit gateway or your Cloud WAN's core network edge. So what essentially you can do is that in my case, for the core network edge in US West 1 region, I can see metrics like in the last 12 hours, how much traffic was sent in or out of that core network edge, how many packets were sent in or out of the core network edge, and in case if there is any traffic drop, what was the reason behind the traffic drop and how much traffic got dropped. So for example, if there was a traffic drop because of a black hole or a no route, you can get these metrics. So what we commonly see customers do is stream these metrics to CloudWatch and then set up alarms as they want. Okay, this is my personal favorite. So with Network Manager, you also get Network Manager events. So these are near real-time events that describe the changes that is happening in your network. So if you think of a transit gateway or a cloud WAN, for example, so let's say if if an attachment is added or if an attachment is deleted, let's say you are using site-to-site VPN, the tunnel comes up or goes down. If you are using BGP protocol for routing between the site-to-site for the site-to-site VPN service, so if the BGP gets established or disconnected, so all of these events are generated within Network Manager. And for any particular event, you can actually go ahead, click on it to get more details. So in this example, I'm showing you the event about one of the routes getting installed in one of my core network edges. So you can quickly get a view of when exactly this event was generated, which account it was, the type of the event. So in this case, it's a routing update. More details associated with the routing, including like which core network edge these routes were getting installed in. Now, what we see customers commonly do with these events is build various kinds of automation on top of these events. One of the most popular use cases that I have seen is using these network manager events. So whenever a new transit gateway, so let's take an example of a transit gateway. So whenever a new transit gateway attachment comes up and this event is generated, what we have seen some customers do is initiate a event bridge workflow that essentially goes ahead and runs an automation to install and to create the routing rules for them and basically automate the whole routing process for those attachments. And if you're interested to learn more about how you can set it up, this blog here provides step-by-step details of how you can do that. So I'll wait for a quick seconds while you are taking. All right. So far we spoke about how you can use resource map and network manager to visualize your topology. Now let's focus on analyzing the traffic within your AWS network. And we are going to talk about VPC flow logs and traffic mirroring here. But first, a question for everyone: how many of you have used flow logs or are familiar with flow logs? Oh wow, I'm glad, because this is by far my favorite tool too. And the main reason is because of the versatility that VPC flow logs offers. And before I quickly talk about like some of the most common uses, how we see customers using flow logs. So what is flow logs? So flow logs basically helps you collect and store information about all the traffic flows within your VPC. Now, when I say information about your traffic flows, it's just not limited to the usual 5-tuple information that folks who are familiar with the on-premises networking. So like besides having things like source destination IP address, source destination port and protocol, you will also have AWS related metadata depending on which version of the flow logs you are using. So you can have fields like information like which AWS services the traffic is going to, which AWS region or availability zone the traffic is originating from. And we will touch upon it a little bit. But coming back to the most common use cases of flow logs, one is monitoring. So basically using flow logs, you can get an understanding of how your overall traffic pattern looks like for your VPC or a bunch of VPCs on which you have enabled flow logs. And this is where troubleshooting also it's helpful in troubleshooting, because it collects information about practically all the traffic flows that is happening within your network. You can, for a particular given resource or a particular given time period, you can go ahead and look at like where exactly the traffic was going on, where exactly the traffic was coming from. So you can again further slice and dice this data to get more information. And we'll touch upon how you can analyze some of the flow logs as well. And one of the more interesting use cases that we have seen is customers using flow logs for cost analysis. So an example use case is that customers networking teams with a centralized network account, and they are hosting their transit gateway in that account. And what they need to do at the end of each month is, depending on which application or business unit sent how much traffic through that transit gateway, they need to allocate the cost. And in those cases, customers, what we have seen customers do is use transit gateway flow logs for doing such analysis. And the other two use cases are around planning and compliance. So because you collect, because customers can collect flow logs and store them in S3 or CloudWatch, they have an idea about all their historical traffic pattern. So they can use that to forecast the future traffic trend to understand or plan accordingly. And then finally, you can also archive your logs for regulatory requirements as well. So let's now talk about where can you enable flow logs. So as I already pointed out, you can enable flow logs at the VPC level itself. Then you also have the flexibility to enable flow logs on a resource basis. So you could enable it at a subnet level, or you could also enable it at an ANI level. And if you are only concerned about traffic that is traversing through your transit gateway, you can enable transit gateway flow logs. And earlier this year in May, we also launched the capability where now you can get ECS related metadata for your ECS workloads. So if you use V7 version of the flow logs, now for your ECS workloads, you will also see a bunch of ECS metadata. Now, when it comes to storing your flow logs, you have three options: CloudWatch, Kinesis Data Firehose, and S3. Now, this choice totally depends on the use case and application. So, for example, what we see is that customers who want to store flow logs mostly for compliance reasons, or who will access these logs infrequently for troubleshooting, they tend to store the logs in S3. Now, for customers who want to monitor these logs or analyze these logs on a frequent basis, they store it in CloudWatch. And one of the added advantages of storing in CloudWatch is that you get access to the native CloudWatch capabilities like CloudWatch Log Insights that you can use to analyze your flow logs. And finally, Kinesis Data Firehose is more suitable where you want more near real-time streaming of your flow logs to any of the destinations. So a common pattern that we see there is that in cases if customers want to stream their flow logs to a third-party security solution where they want less lag, they go for something like Kinesis Data Firehose. Now, with respect to analyzing your flow logs, I will cover CloudWatch Log Insights shortly, but QuickSight and Athena are another common ways we see how customers analyze flow logs. All right. A very common question is, there are up to now, I believe, 8 versions of the VPC flow logs, and which version of flow logs should I be using? So I'll explain the difference with a simple example, and I'll compare version 2 and version 3 of the flow logs here. So let's take a very simple example where I have an instance D in a private subnet sending traffic to the internet through the NAT gateway. And now what I want to accomplish is, I want to know the IP address in the internet where this traffic is going to. So what I'll do is, I'll enable version 2 of the flow logs first on the instance D that is in my private subnet. So among other fields in the version 2, what you will see is a source address and a destination address field. But if you will notice, the destination address field is 10.1.2.14, which is pointing to your NAT gateway. So what will end up happening is, now because you want to know the destination address in the internet, you will need to create the flow logs on the NAT gateway, enable flow logs on the NAT gateway, and then once you start getting those flow logs from the NAT gateway, you will need to correlate both of these flow logs to essentially figure out where the traffic is going in the internet. But now let's say I have version 3 of the flow logs. So, and I enable version 3 of the flow logs on the instance D in the private subnet. So now you will notice two additional fields here, the packet source address and the packet destination address. So this packet destination address field, what it essentially tells me is the actual final destination of that packet, which is in this example 1.2.3.4 in the internet. So you can see here that by using just version 3 of the flow logs, how my job of identifying where the traffic is going to the internet through that private subnet became much more easier. And what we are seeing right now is that customers are increasingly using version 5 of the flow logs, because version 5 of the flow logs also have information around like which AWS service the traffic might be going to. And in case you are using transit gateway, then you should use version 6 of the flow logs. And for ECS workload where you would want ECS related metadata, you can use version 7 of the VPC flow logs. All right. One of the other things that I want to talk today is about using CloudWatch log insights for analyzing your flow logs. And one of the recent capabilities that CloudWatch team launched that can make you analyzing your flow logs easier is the query generator. So what query generator does is that it allows you to express the analysis that you want to run in plain language. So in this case, what I'm trying to get is, for the past 1 hour, I want to get the average minimum and maximum byte of traffic that was sent for my source destination pair. So now I express this in natural language in the query generator. And when I click on generate query, what essentially CloudWatch does is that under the hood, it uses large language model to convert this query into a CloudWatch query language. And this is a simple example, but please go ahead and try some complex examples as well. And then you can go ahead, run your query, and within seconds you can see the results here for the past 1 hour. So next, these are some of the useful links around how you can learn more about the various versions of the flow logs, how if you want to analyze your flow logs using Athena as well as QuickSight. While folks are taking links, so with next, Ankush is going to talk to you about traffic mirroring and also some of the various features within the troubleshooting category. Thank you.
All right. Thank you so much, Nishant. Okay, so we talked about VPC flow logs, which give you a high-level insight onto your traffic flows and traffic mirroring or traffic patterns. But what if you want to inspect your data in the real time, your traffic in the real time? You want to do some content inspection, you want to do some threat monitoring, or you want to perform some troubleshooting on your data, on your traffic. That's where the traffic mirroring comes into the picture. Traffic mirroring allows you to mirror or capture your inbound and outbound traffic coming to your ENI, which is attached to your EC2 instance, and send the data to a different destination, and we call it as a target. And the target could be any of your appliances, which is sitting in the same VPC or in some different VPC. It also allows you to filter out the data, because you might be getting a lot of data from different protocols, but if you want to filter out that I only want to capture the SSH or HTTPS traffic, you can put the filter and you can capture only that particular data. And not only that, if you want to send this data to a different place, to a different appliance based on your protocol, you can do that as well by creating the sessions. So what are the key advantages of or key benefits of traffic mirroring? The first, you don't need to deploy any agent on the source or the destination. Traffic mirroring takes care of that. Second, there's no risk of any tampering with the captured data. So security is the biggest concern for everyone, and you don't need to worry about that. So traffic mirroring takes care of that as well. And then lastly, like I mentioned, that if you have a use cases where you want your SSH traffic to be sent to a different destination, different appliance, HTTPS traffic should go to a different appliance, you can do that as well. So where these appliances can be? These appliances can be in the same VPC where your source is. These can be in a different VPC, and those VPC source and destination are paired with each other by peering connection or by transit gateway. Or if you don't know how much traffic you're going to get, and at times it may have that you get a lot of data, at times it may happen that you're getting very less data, you can put these appliances behind a network load balancer in an auto scaling group. so that you can scale out or scale in based on how much data you are getting in. And we have customers who want to use the third-party appliances as well. So for those users, you can put your appliances behind a gateway load balancer and use the gateway load balancer endpoints to send your traffic. All right, so we talked about observe section and we talked about analyze. Now let's talk about what all the different AWS tools are available for you to troubleshoot a network. So one of the key tools for network troubleshooting in AWS is the VPC reachability analyzer. It's a configuration analysis tool which enables you to perform connectivity testing between a source instance and a destination resource. Like you have a EC2 instance running and you want to check that whether the NAT gateway, the connection is there or not, so you can use VPC reachability analyzer to perform that kind of analysis. It also helps you to perform the configuration intent verification as well as automated validations. Let's understand how it can help you with a simple architecture. Here I have two VPCs connected with each other by transit gateway. I have instance A which need to communicate with instance C, but the connectivity is broken. Now there could be several issues in that. If you go try to do that manually, you might need to check the security group. Maybe the rules are broken there. Maybe knuckles is creating a problem, or the route table could be creating an issue here, right? But let's see how VPC reachability analyzer can help you to do the analysis on your behalf and find it out that why these two instances are not able to connect with each other. So for that, we'll start by creating an analysis. We'll provide our source resource, in this case our instance A. We'll provide our destination instance, which is our destination instance ID, and we'll choose the protocol and we'll create the analysis. In just few minutes, reachability analyzer will perform the analysis and give you a detailed result why these two instances are not able to communicate with each other. Like it's mentioned here that the route table does not have a route to the destination, that's why these two instances are not able to communicate with each other. It also gives you option that you can click on the particular resource and it will directly take you to the particular screen of the route table and you can fix the problem. Further, if you want to dive deeper, want to understand that how your traffic is flowing from your source to the destination, you can use the path detail as well, where you will get all the hops from your source to the destination, and it also pointed out which particular hop between this path is creating the problem. So if we look from our architecture, this is the route table which was causing the problem. We can fix that problem and we can rerun the analysis. This time you will see that VPC reachability analyzer tell you that these both instances are reachable. And if you go to the path detail, you will get all the hops without any issue. All right, so we talked about how you can run this analysis manually. But large organizations want to make sure, or they want to automate this process. They want to make sure that the moment any network change happen in my organization, I want to run an analysis. I want to make sure and get notified that whether this particular change is breaking something in my network before it escalates. So for that, we have put together a sample architecture here, where the moment you change the security group, a workflow will be initiated, and the workflow will kick up the Lambda function, which will run the reachability analyzer, perform the analysis and find out if there is any connectivity broken, it's going to notify it to you by a SNS notification. So if you want to learn more about similar kind of architecture, you can scan this QR code and read about this blog post. Okay, you see few more people are taking some. All right. Okay, so we talked about two capability that you can run this analysis manually, you can automate this process, but for both of those you need a great networking background. But what about the users in our organization who does not have any networking background? We all do have, right? So for those users, you can use VPC reachability analyzer with Amazon Q. Here you can provide your question in a simple plain English language. Hey, why my instance is not communicating with instance C? I didn't provide even the instance ID here. I didn't tell Amazon Q or this VPC reachability analyzer that in which VPC these are lying, what are the security group, what are the knuckles, how those VPCs are connected with each other. Didn't provide any information. Amazon Q did all the hard work for us behind the scene and find out what all the VPCs are, what all these instances are, how these are connected with each other. And in just few minutes, it gives us the detailed analysis that why these two instances are not able to communicate with each other. Like you clearly see here, it mentioned that instance A is not able to communicate with instance A because you don't have a route in your route table. It's not even stopping there, it's also telling you or giving you the steps how you can mitigate it. It's clearly telling you that how you can add a route to your route table, and from there you can mitigate this problem. So if you have people who does not have networking background, so don't worry about that, we have a tool for you. If you have any troubleshooting problem, you don't need to go to a network geek and ask, hey, why it's not working. You can try out this tool. Okay, so we talked about VPC reachability analyzer, which give you capability to perform point-to-point connectivity testing. What about you want to perform a detailed analysis on your network, right? You want to understand what all possible paths you have starting from your inside your VPC going outwards, or what all possible paths are coming to your VPC. For that, you can use network access analyzer. With network access analyzer, you can define your network access requirements, you can run the analysis and identify any network paths that does not meet your requirements, and you can take actions from there. By default, we provide you 4 default scopes: VPC egress, ingress, and IGW ingress and egress, and all these 4 scopes perform a different solve a different purpose. Like if we talk about VPC egress, it means that you are talking or you're getting all the possible paths which are starting from your ENI inside the VPC going outwards towards transit gateway, internet gateway, VPC endpoint, or peering connection. So let's take our sample architecture which we built in the starting of the presentation and try to run the same analysis on that by using VPC egress scope. Like in this, you will see in the scope we is having the source as the network interface. That means all the network interfaces in my architecture, and all the possible paths destinations are either internet gateway, peering connection, endpoints, and so on. So what it's going to do, it will find out all the combination of paths starting from the instance or ENIs going towards outward. And in just few minutes, once you analyze this traffic, you will get the detail or display for every source and destination resources that has connectivity showing paths from your ENI in your VPC to IGW, TGW attachments, or VPC endpoints, and so on. And for each finding, you will also get, it also provide you the detailed hop by hop path for source and destination, giving you full visibility into how the traffic is following through your network. In addition to that, these 4 default scopes, if you want to create a different scope or custom scope, you can do that as well. Okay, so we talked about how you can troubleshoot your network. We talked about how you can analyze or you can get an overall picture of your network. Now, let's shift our focus and talk about how you can troubleshoot the network from the performance perspective. Here I have a simple architecture. I have a workload running in my VPC and is trying to access some data from S3. It's fronted by a load balancer, and we have users over the internet who is trying to access this application. We have users sitting on-prem who are trying to access this application via direct net connections. But at times, these users might be complaining about the performance of the application, and it becomes very difficult for the network as well as the application team to find out where the issue is, whether the issue is lying over the internet, customer end, in my on-prem, DX connection, or my AWS or AWS workload running in AWS. So I'm going to talk about 3 different features today which will help you to mitigate or which will help you to identify where the problem is. So the first service is Internet Monitor. So like I mentioned, we have an application running in AWS, and we have customers or accessing this application over the internet from all over the world. But at times they are complaining that performance is degraded. Now, it can be unclear at times that where the problem is. The problem could be at the customer end. They might run or install some patch at the laptop, and that might have screwed it up. There could be issue at the AWS hosted application as well, or within the AWS, or there could be issue over the internet as well. So that's where the Internet Monitor will come and help you out to find out these kind of issues. With Internet Monitor, it helps you to see how internet issues are impacting the performance and availability of your AWS applications. It reduces the diagnosis time from days to minutes by pinpointing whether the issue is with your AWS application or is outside of the AWS over the internet. You can also monitor problems faced by your users across different geographic locations and networks, all without writing even a single line of the code. It even offers suggestions to improve your user experience, like by using alternate AWS region, AWS service, or routing your traffic through a different region. So how does it work? It consists of 4 key components. First, you will start selecting by the AWS resource, and we support 4 of the resources right now: Amazon VPC, Network Load Balancer, Amazon CloudFront, and Amazon Workspaces. Then we specify how much percentage of traffic we want to monitor, and this is what we create our traffic profile. Next, what we do, we overlap this traffic profile with the internet weather map data, and this is the data which AWS is keep on collecting over the time from different edge locations, from different internet providers, and from different various locations. And by overlapping your traffic profile with this internet weather map data, Internet Monitor provides you with the real-time insights and optimization suggestions right into the console, which will help you to enhance the performance of your end users. So how does it look like from the dashboard perspective? As you can see here, that you will get visibility into somewhere from 9 AM to 1:30 PM. Your end users were facing some problem while accessing your application. If you want to dive deeper, it also gives you that how much round trip time it was taking, how many bytes were transferred or impaired during that time. And it's not stopping here, it's giving you more information like what particular location was impacted and how much traffic that particular location was impacting for your application. So by using these matrices, you can clearly find it out whether the performance of your application was impacted by internet or not, so that you can rule it out one of the component and then you can focus on something else. Okay. So we discussed how you detect problem over the internet. Now let's see how you can detect problem over the hybrid connections over the DX. So in this case, we have application running in our VPC is connected with on-prem via DX connection. We have 2 of the connection for high availability in path X and Y, and we all know that portion of the DX is managed by customer or the partner, and the portion is managed by AWS. In this case, our application is accessed by on-prem users, but the application is very sensitive to any packet loss or any latency. So what happened that we get some kind of packet loss happening in one of our path X. Now our users are complaining, hey, we are seeing some kind of performance issue with our application. But when we check from the DS perspective, because it's using BGP, BGP is built on TCP, which has retransmission, and your BGP connection might not flap, like it's keep on running and you say that it's up and running. Then how you identify? That's where the synthetic monitor comes into the picture and help you out. So with synthetic monitor, it provides you visibility into the performance of the network, connecting your AWS hosted applications to your on-prem destinations. And it also allows you to identify the source of any network performance degradation within minutes. It is very straightforward to set up. You will provide the subnet where your workload is running. You will provide the subnet or the destination where the workload is on-prem, and in just few clicks it will be up and running. One other thing to keep in mind in this, that again you don't need to install any agent on the source or on the destination. And also it also provide you or enable you to detect issues faster and provide KPI based health indicator and consolidate all the metrics at the same place in your CloudWatch. So to start, you will create or select your workload subnet where the workload is running. What AWS does, we drop 2 ANIs in each of your subnet for high availability, and that creates your probe. And at the destination end, you need to provide us the IP address, and that IP could be your router IP address, could be your server IP address, or could be your loopback IP address. So once we have that information, we create a probe, and what does it does that it starts sending packets to your destination IP address and start collecting all the information. So we get 3 different metrics with this. One is network health indicator, the other one is packet loss, and the round trip time. So network health indicator matrix gives insight into the performance and availability of the AWS direct connected paths. using anomaly detection to spot any issues in the AWS managed network route. So, remember we talked about we have two portion, customer managed, AWS managed. So, network health indicator will provide you information if there is any performance degradation on the AWS side of the network. So, that will clearly tell you that whether the performance was impacted because of the DX which was managed by the AWS. In addition to that, you will get packet loss metrics as well, and this metrics measure the percentage of total package that sent and record the number of transmissions that didn't receive any associated responses. So, from there you can get how much packet loss you have having or happening over the DX connection, and based on that you can realize that whether the packet loss is the another cause which is impacting your performance or your application or not. Similarly, the round trip time, we get the send the packet, receive the response back, and based on that we calculate in milliseconds and give you the metrics that how much round trip time is taking and whether the latency is high or not. Based on that you can take an action. All right. So, we talked about two services, we understood that how we can mitigate or how we can identify the problem happening over the internet. We also talked about how we can identify problem happening over the DX connection. Now, let us shift our focus and talk about how you can identify problem happening within the AWS. So, I am happy to talk like this is the new feature we launched this Sunday just before the reInvent, Network Flow Monitor. This is a new capability we added where you get insight or near real time insight into network performance, including packet loss, latency for traffic between EC2 instances and any other AWS service like S3 or the DynamoDB. In this, you have to install a lightweight agent on your EC2 instances, and what it does that it uses your TCP connections and start collecting all your metrics data. And the data is then sent into Flow Monitor, which analyzes the data and tells you what are the top contributor for the performance of your, which is impacting the performance of your application. And it's ideal for both network as well as developers, and it provides actionable insights right into your CloudWatch. Okay, so like I mentioned, you install a lightweight agent or on your EC2 instances. So, what it does that in our example, like we had EC2 instances talking to S3 bucket. So, it capture all the data transfer between your EC2 instances to your S3 bucket, and Flow Monitor analyze the data and create that how much data we are transferring between the instances to S3 bucket, and then it will tell you that what is the top contributor for the data transfer. And if you want to dive deeper into that, you can create a monitor for that particular top talker, and you can get more details, like you will get the network health indicator, you will get round trip time, you will get retransmission data or the data transfer happening between those two. Network health indicator, again it will tell you that there were AWS network issue for the network flows that your monitor has created, and when the NHI indicator, the network health indicator is degraded, that means that there is an issue on the AWS side of the network. So, you can focus accordingly whether is the AWS issue or your application issue. In addition to that, you get the network traffic summary where you get the round trip time your packets are taking, you will get your retransmission, and if there is any retransmission errors are happening, as well as the data transferred, how much data is transferred. So, they are the few of the graphs you will get on the same screen, the round trip time, retransmission and the data transferred. All right. So, these are some of the QR codes which you can take a photo and read about more about these features. Okay, so we covered what all we covered today. So, we talked about that how complex your architecture could be, how big your architecture could be, and to monitor, to troubleshoot, you need different set of tools. So, we talked about you can have a resource map, you can have a network manager which give you capability to have a overall view of your architecture, right. Then you can analyze your traffic by using the VPC flow log or by using the traffic mirroring. Then we talked about the troubleshooting tools, like if you want to perform point-to-point connectivity testing, you can use VPC reachability analyzer. If you want to have a overall picture of your all the traffic going out and in, or all the networks within your VPC, you can use network access analyzer. And then in the last, we talked about what are the 3 tools you can use to identify whether the problem is over the internet or over the DX connection or within the AWS. If you want to learn more about these topics, we have another session coming, I think in 1 hour 30 minutes. That's a chalk talk, and they will be covering similar kind of topic. You can go and ask any question if you have from them. They'll be happy to answer. Yeah, so that's it for today's session, and thank you so much, folks, for joining us on Thursday afternoon. Thank you, and please don't forget to fill up the survey.